warahmatullahi wabarakatuh. My name is Laily BINTI ZAHAFIAN. Right now, I would like to present about my research titled The Effectiveness of Food Waste Compost on Growth Performance of Okra. This is the agenda of a review throughout the slides. First of all, let's start with the introduction. The introduction for this research talks about the three things which are subject: food waste, treatment, composting, and the parameter growth performance of okra. Food waste plugs the world with 1,000 billion tons yearly and Malaysia 15,000 tons daily. Landfills overflow, causing stench, pests, and harmful gases. Composting offers a solution, transforming waste into nutrient-rich compost. Okra, a historical vegetable, could thrive with composted food waste. This research explored composted food waste as a sustainable okra fertilizer, comparing its influence to traditional methods, such as by using the commercial fertilizer. The goal here is for eco-friendly waste management and successful okra growth performance. For the problem statement, food waste clogs landfills, releases harmful methane, and stinks. Studies show it can be a major source of greenhouse gases. Chemical fertilizers used in farming can also hurt the environment. Food waste compost might be a better option. Research suggests okra grows better with compost than chemical fertilizers. More studies are needed to see if food waste compost specifically helps okra, but it could be a win-win for waste reduction and sustainable farming. Three objectives were suggested here. First objective, to determine the nitrogen, phosphorus, and potassium ratios from different food waste materials. Second, to investigate the influence of food waste compost on soil health for the efficiency of okra nutrient uptake. The third one, to determine the effects of food waste fertilizers on okra growth performance. This project tests food waste compost as a sustainable okra fertilizer. It will compare okra growth using campus food waste compost to a group. This will analyze the compost nutrients and grow okra under controlled conditions with different compost treatment. Plant height, leaf number, and overall plant size will be measured. This also assesses the okra's fruit yield, width, weight, length, and quality. This research aims to find out if food waste compost can be a green way to boost okra production. Last part for chapter 1, significance of study. Popular okra suffers from risky synthetic fertilizers. Food waste, a global issue, can be composted for nutrients. This research explores how compost food waste affects okra growth. This research will measure plant size, yield, and fruit quality. The goal: find a sustainable, long-term alternative to chemical fertilizers for okra. This can guide future studies on food waste composting and eco-friendly farming. My chapter 2 classify into three different subheading. First is food waste. So for the subheading for food waste, the important parameter 1 is suitable food waste material. Creating a successful compost requires a balanced mix of ingredients, just like a good recipe. Taught by Ginia et al. 2019, identified three key categories, which is the first category is green, which is nitrogen rich. This jumpstart decomposition, providing moisture and nutrients for microbes. Example include fruit and vegetable scraps, coffee grounds, and tea bags. The second one is browns, which is carbon rich. Browns balance nitrogen levels and add structure for air circulation. They include wood chips, cardboards, and leaves. And the last one is the avoid items, which are meat, dairies, and greasy foods, can slow decomposition, attract pests, and emit bad odors. The second parameter under 2.9 tell about nutrient content. The specific ingredients used in compost significantly influence its nutrient profile. According to Nasir and Kazi 2012, studied the nutrient content of food waste compost made from various fruit and vegetable scraps. Moisture content varied greatly, with bananas, carrots, and cabbage having the highest. Ash content was highest in oranges, bananas, and potatoes. Nitrogen, crucial for plant growth, was generally low, with carrots having the most. So the second subheading will fall under growth performance of okra. Sorry that I mentioned it wrong previously. It is not compost, but it is growth performance of okra. So the first parameter talks about the environmental factors. So here is the information on okra's growth factors. In short, which is the okra is heat lover. The okra thrives in warm weather between 24 until 35 degrees Celsius. They are thirsty seedling. Water is crucial for seed germination and plant growth for okra. They are water stress boost, where studies shows less water means less growth of okra in terms of height and fruit. And then they are water warrior. Even in hot weather, good moisture helps okra growth and even improves pod development. And then they are light lover, but not too much. Okra needs light for photosynthesis, with stronger light making thicker leaves. Other parameters There's four physiological factors required or needs by okra. They need warm water for sprouting and growth and balanced light. Strong light of vertical leaves. So for the food of okra needs a well-rounded diet of nutrients, especially nitrogen for growth, phosphorus for roots and flowers, and potassium for overall growth and reproduction. The NPK ratio needed, which is the ideal mix of NPK, depends on okra type, climate, and soil. Studies show moderate or high NPK can work, but uptake depends on factors like moisture, air, and soil temperature. The last subtopic is okra overview, where the first parameter is about biochemical composition and growth requirement. Okra is a tropical or subtropical crop native to Africa but now grown worldwide. It thrives in warm temperature 21 until 30 degrees Celsius and requires consistent moisture throughout the growing season, while drought-tolerant reduced water availability can significantly lower yields. Okra is a good source of vitamins, minerals, and fiber. The pods are high in vitamin C, calcium, and potassium. Seeds contain protein and oil rich in linoleic acid and essential fatty acid. Okra research is ongoing with a particular interest in how using decomposed plant materials like wood, ash, cocoa, husk might affect soil fertility, fruit development, and okra production. Okay, so for the second parameter under this subheading is okra quality and nutritional value. Okra is a good source of vitamins, minerals, and fiber. It's particularly high in vitamin C, potassium, and fiber. They have potential health benefits. Studies suggest okra consumption may help lower cholesterol, promote gut health, and even manage blood sugar. Their seed also has potential. Okra seeds are high in protein and oil, making them a potential source of vegetable oil and protein supplements. Okra also can function as traditional medicine. Okra has a history of use in traditional medicine for various ailments, including ulcers, diabetes, and kidney problems. Move to research flowchart. This is the flowchart for this research project on the effect of food waste compost to soil health in correlation with okra growth performance. This flowchart shows three objectives and their respective methods. Objective 1 is to determine the nitrogen and phosphorus P and potassium K ratios in different food waste materials. The method involves collecting food waste and using a technique called inductively coupled plasma mass spectrometry to measure the NPK content. The second objective is to investigate the influence of food waste compost on soil health for efficient okra uptake of nutrients. The method involves creating compost from food waste, applying it to soil, planting okra in the conditioned soil, and then assessing the health of the soil. Soil health assessment will likely involve measuring factors like nutrient levels, microbial activity, and water drainage. For the objective 3 is to determine the effectiveness of food waste fertilizers on okra growth performance. The method involves collecting data on okra growth in soil amended with food waste compost and likely comparing it to a control group growing in non-amended soil. This data collection might involve measuring plant height, leaf area, okra yield, and other relevant metrics. For the procedures details, first and first is the food waste collection. Food waste were collected at college in UKM and Hair Garden. Garbage were also collected because it can be helpful to improve compost quality, plus it share a similar component like lignin, cellulose, and many more. The second steps were preparation of food waste. Food waste composting process with EM as a helper. The EM were produced to boost the composting yield. Rate here, it used two type of EM, which are Takakura EM and fruit EM. Next, the food waste specification was where and it were inserted into the food waste in the rotary drum and composters. Compost specification, where a moisture content test was conducted to ascertain the percentages of water in the samples. A pH meter was used to assess pH value. And NPK analysis were conducted by using ammonia nitrogen test 4500 ammonia for measuring nitrogen and inductively coupled plasma mass spectrometry for using potassium and phosphorus for measuring potassium and phosphorus. The third step is for soil analysis preparation, production of soil conditioner by two parameters, which were soil conditioner with EM and without EM, application of soil conditioner to the soil. The step tested 3 soil treatments, no fertilizer, NPK fertilizer, and an EM soil conditioner. Each treatment was randomly assigned to plots in 4 blocks. Soil conditioners were applied 3 weeks before planting until into the soil 15 cm deep. Plots and 3 rows of 5 plants each spaced 1.5 meter between rows and 90 cm between plants. Only the center row of each plot was used for data collection. Outer rows guarded against edge effects and pests or diseases. For soil health assessment, soil conditioner samples were air dried and analyzed. Soil samples were taken before treatment and during transplanting. 4 soil samples per treatment were collected from an 18 cm depth. Standard methods were used to measure soil health, pH, potassium, calcium, magnesium, organic matter, nitrate, ammonium, phosphorus, and sodium by using spectrometry. The second and last step was, of course, okra sowing. First is 3 BINTI in blocks. At 18 blocks, 2.2 meter times 2.2 meter were set up in 3 blocks to test fertilizer on Okra. Each block had 6 plots for 6 treatments. No fertilizer, regular NPK, high manure, high compost, half NPK and half manure, half NPK and half compost. The experiment used a randomized whole block design. Okra seeds were planted 60 cm apart with 45 cm between each seed, 2 seeds per spot. After seedling emerged, only the strongest one was kept in each spot. The plots were watered as needed, weeded regularly, and pest or disease control was applied when necessary. For okra growth performance data collection, several okra characteristics were measured here, such as length, circumference, count, fresh weight, plant height, and number of leaves. Following the last harvest at maturity, the dry weight of the shoot and root were measured. Last but not least is the statistical analysis of the okra growth performance. One-way analysis of variance, Dukan's multiple range test, SPSS version, 12 and Excel, 2 statistical programs were conducted. Expected results for objective 1, nitrogen highest in bin B, compared to bin A, C, and D, while phosphorus highest in bin A, followed by bin B, C, and D, and the last one is potassium found highest in bin D, followed by bin A, B, and C. Expected result for objective 2 in investigating soil health. Similar levels of total nitrogen, potassium, phosphorus, calcium, magnesium, zinc, iron, copper, total carbon and carbon nitrogen ratio for both with EM and non-EM. Total nitrogen, phosphorus, potassium, calcium, magnesium, iron, molybdenum, copper, carbon, and CN ratio were less variable in the EM soil condition. Expected result for objective 3, which is for the okra growth performance. For the plant height, compost increased plant height compared to the control. It wasn't as effective as poultry manure, treatment 3, or the 50% NPK with 50% poultry manure mixed in the treatment form. For the shoot weight, compost treatment, which is treatment 5 and treatment 6, resulted in moderate shoot weight increases compared to the control, but not as substantial as the 50% NPK with 50% poultry manure mixed treatment 4 or full poultry manure treatment 3. While for the root weight, like poultry manure and NPK, compost treatment significantly increased root weight compared to the control. Interestingly, the 50% NPK with 50% compost, which is treatment 6, had similar root weights to the 50% NPK with 50% poultry manure in treatment 4, suggesting both compost and poultry manure can work well with NPK for root development. Lastly, for fruit production, similar to poultry manure and NPK, compost application, treatment 5 and treatment 6 did not significantly affect fruit size, which is length, circumference, and weight, compared to the control. The number of fruit per plant determined overall yield, while compost treatment 5 and treatment 6 increased fruit number compared to the control. It didn't perform quite as well as the 50% NPK with 50% poultry manure in treatment 4. In terms of total fruit yield per hectare, full poultry manure was the best, followed by the mixture of 50% NPK and 50% poultry manure in treatment 4. Compost treatment 5 and 6 yielded more than the control and full NPK, but less than treatment 3 and treatment 4. The project is expected to take about 16 months, starting in October 2024 and ending in January 2025. Here's a breakdown of the activity.